Good morning, students. This is Venkatesh. Today we will learn about water turbine, which is fifth unit. Let us know the definition of turbine. So turbine is a device which converts the hydraulic energy into mechanical energy. So this mechanical energy further utilized as electrical energy by using generator. And the definition of pump. So pump is a device which converts the mechanical energy into hydraulic energy. So in the thermal power plant, we use coal as the working substance. We use coal as the main ingredient. So from the coal we produce the steam. So from the steam we generate the electricity power by using steam turbines. Whereas in the hydroelectric power plant we use water as the substance. From the water we produce electrical energy by using water turbines. Let us know about the layout of hydroelectric power plant. So this is the structure, construction of the hydroelectric power plant. So you can, that we should know the basics of main components. So first one is the reservoir. So reservoir, what is meant by reservoir? So reservoir is a construction where the water is stored in the rainy season and available in the dry season. So that is the reservoir. The topmost surface of the water in the reservoir called headdress. So this is the headdress is a technical word which is used in the hydroelectric power plant. And the next thing, dam. So dam is a cement construction where we construct this dam across the river to store the water in bulk quantity, and to form the reservoir we construct this dam. So another one is trash rake. So trash rake is act as a filter to trap the debris. DERBRIS, debris. Debris means nothing but dusty particle, that means which is large size dust and papers and unwanted materials called debris. So to trap this debris we use trash rake before the inlet of the tunnel. And the next thing is sluice gate. So sluice gate is the act as a wall to enter into the water into tunnel. So it is act as a opening of the tunnel. Another thing is tunnel. So tunnel is the underground construction. So it is a passage of underground construction to allow the water to the penstock. So to carry the water from the reservoir to penstock called tunnel. And one more thing, this is the surge tank. Surge tank SURGE, surge tank. So the purpose of surge tank is very crucial in the hydropower plant. So the main function of surge tank is to avoid the water hammer effect. So what is meant by water hammer effect? So when we close the valve at the outlet of the penstock, there will be a high pressure created and there is a high pressure waves formed at the end outlet of the valve. So this high pressure waves passes to backside and damaged the surface of the penstock. So to avoid this damage of the pipe or penstock, we construct the one surge tank. And the another usage of the surge tank is if there is any sudden shortage of the water in the at the outlet of the nozzle, this surge tank water will be recover the shortage. So that is also another advantage of surge tank. And the next important construction is penstock. This is penstock. So penstock is a pipe which is in the form of conduit and act as a passage of water which is connected to the tunnel to the nozzle. So here one word, conduit. What is meant by conduit? So generally the pipe will be having some length. So for the here the penstock is large size, that means around 200 to 300 meters and more. So to construct this large pipe, we attach the pipes in series. That means we join the each and every pipe by nut and bolt system. So this attachment, this formation of pipe is called conduit. For the single pipe we call pipe. For the joining of series of pipe, more than one pipes, called conduit. And the next thing, nozzle. So nozzle is used to deliver the water from the penstock to the turbine, and we can also know the function of nozzle. That means it creates the high velocity of the water or fluid and simultaneously reduce the pressure of the water. So by increasing the velocity of water, we obtain kinetic energy, so utilized in the turbine. And one more construction is turbine. This is the turbine. From the turbine we connected this shaft to generator, so the power will be produced in the generator and pass it to the powerhouse. Here the whatever water used in the turbine we send it to the tail race. That means the wastewater reserved in this tail race. So the difference between head race and tail race is called gross head, HG, gross head. So this is the main layout of the hydroelectric power plant. So just draw the diagram and explain the each and every component. Here we need to know some important basic definitions which are used in the problematic. So first one is the gross head. So gross head is Gross head is the difference between tail race and head race, called gross head. Depending upon the gross head, we can classify the turbines: low head, medium head, high head turbines. And the second thing is net or effective head. So it is the difference between gross head and head loss, H equal to Hg minus Hf, where Hf is equal to total losses, that we know already in the second unit, 4f Lv square by 2 Gd, where L is the length of the penstock and the V is the velocity of water and the D is the diameter of penstock. So from these values we can calculate the total losses and substitute these losses in the above formula to obtain effective head. And one more thing is efficiencies. So there are mainly 4 efficiencies. So one is the hydraulic efficiency. So efficiency, wherever you see the efficiency term, that is simply say that ratio of output by input. But the difference is, what is the output, what is the input? If you recognize what is the output and what is the input in the system, that concerned system, we can easily